session. In this class, we are going to discuss about the statically determinate beam and statically indeterminate beam. In the previous class, we have discussed about beam and what are the different types of beam, as well as the parameters which involves how to classify a beam, like a number of supports, type of supports, location of supports. So those things have been discussed in the earlier class, and today we are going to statically determinate beam. Before going to statically determinate beam, we should know what is a statically equilibrium equation. Statically equilibrium equation. What is an equilibrium? Equilibrium means the net effect of forces is equal to 0. That means the resultant will be equal to 0. You know that a resultant is nothing but a single force which would produce the same effect as the system of forces produce the effect. But in equilibrium, the effect will be nullified. Whatever the forces acting towards right side, the same amount of forces acting towards the left side in the same line of axis. That is called the equilibrium. Okay. So statically equilibrium equations. It's nothing but sum of the forces along x-axis is equal to 0, and the sum of forces along y direction is equal to 0, as well as the sum of moment about any point that is equal to 0. Okay, these three equations are called statically equilibrium equations. It is along x directions, that is both horizontally as well as vertically, means I have put y axis, and this is called a bending moment. Bending moment about any point, if you take the sum of bending moment about any point is equal to 0. These are called statically equilibrium equations. Now I am coming to this point, statically determinate beam. A beam, okay, which can be solved, that means all the unknowns, that means the support reactions can be solved by using the statically equilibrium equations alone. That beam is called a statically determinate beam. Okay, so statically determinate beam means the support reactions. Generally, the unknowns are called support reactions. So those things are solved by so in a beam, the unknowns are called support reactions. So those support reactions can be solved by using these statically equilibrium equations alone. The beam is called statically determinate beams. Then what is statically indeterminate beam? Here, okay. Another one is called a statically indeterminate beam. In a beam, the unknowns of support reactions cannot be solved by using only these three equilibrium equations. We need another equations to solve the problem, so that we can find the support reactions of a beam is called a statically indeterminate beam. These equations are not sufficient to solve the beam. To find out the support reactions are called statically indeterminate beams. So what are the statically determinate beams and indeterminate beams? What are the examples? For statically determinate beam, cantilever beam. Okay, cantilever beam is an example for statically determinate beam, and a simply supported beam. Simply supported beam is an example for statically determinate beam. and overhanging beam. It is also an example for statically indeterminate beam. Okay, the cantilever beam PB and SSB simply supported beam. This is overhanging beam OHB, overhanging beam are all the examples for statically determinate beam. Here the number of reactions, okay, for a fixed 3 unknowns, 3 equations are there. So it is a statically determinate beam. We can find all the unknowns. And for a simply supported beam, here we have a 1, 2 support reactions. In this we have another. Okay, but there is no moment. We have only 2 equations on the forces, sigma m fx, sigma fy. These two are 0. So remaining, okay, so we have only 2 equations, 2 unknowns we can find. So there is no bending moment. If you apply, we can get the thing. As well as here also 2 unknowns. Okay, if lateral loads, the horizontal will not come into picture. Same thing, sigma fx and sigma fy. We can apply both the things. You will get the support reactions. These are the examples for statically determinate beam. Okay. Next, let's go for the statically indeterminate beams. So what are they? So now we go for statically determinate indeterminate beam. Okay. Let's have a fixed beam. Even though 2 supports, but in the fixed beam we have 2 support reactions. So not only 2, another bending moment. Okay, 3 support reactions, and here also 3 support reactions. So totally the unknowns are 6. So having 3 equations, we can find the all unknowns. So it is coming under statically indeterminate beam. And one more thing, cantilever and having another support at the end or in between. So here also we have the number of support reactions, 3 plus 1. So totally 4 unknowns. So having 3 number of equations, we cannot find all the unknowns. Okay, so these are all coming under statically indeterminate beam. So that's all about statically determinate and indeterminate beam. So what are the statically equivalent equations, and how can we identify statically determinate beam and statically indeterminate beam by using the statically equivalent equations and the unknowns. Okay, you just go with the number of type of beams and having the unknowns and identify the beam coming under statically determinate or indeterminate. Okay, thank you.